Hey everybody, this is our video on long bone anatomy and microscopic bone anatomy, and you'll see how those themes tie together here in just 1 second. I'm not trying to ignore the other kinds of bones, short bones, or irregular bones, or flat bones, but it's easiest to look at bone growth when you look at long bones. So we'll focus our attention here and then work our way into the microscopic part of bone. Okay, maybe you recognize this bone, what kind of bone this is. Maybe you don't. This actually is the right humerus. Get you oriented there. And obviously you see a bit of a frontal section so we can see inside of the bone. So let's start with gross anatomy and name the parts and kind of work our way around here. The bone clearly has two ends, a proximal epiphysis and a distal epiphysis. Epiphysis refers to bone ends, and obviously proximal means this is the part that's going to be attaching to the main body axis. So this is going to be the end for your shoulder, if you will. This is going to be where your elbow is. And then diaphysis is the shaft. It's in between. There's a small region here, and sort of see it here. This is the metaphysis. Meta means in between, so it's a small zone between the distal and the distal epiphysis and the diaphysis here, the proximal epiphysis and the diaphysis here, and we'll talk about what that zone refers to in just a second. The bone is covered by a membrane called the periosteum. You see it kind of pulled away here, and it's this little thin membrane that goes all the way around. And that membrane, peri, means on the outside of. So the periosteum is a membrane, and contained within the periosteum will be some friends of yours we just met in the previous video. That's where we find those osteogenic or stem cells that help make new bone tissue. On the lining of the inside of the bone contains another membrane called the endosteum. You see it here as well. Endo means on the inside. So this is going to be another membrane layer. And once again, you're going to find osteogenic cells, because when bone grows, it grows both on this surface as well as on the outer surface. And we'll see how that works when we talk about bone growth. Some other regions to mention here. Around the epiphysis here, and you see it here as well, you see a kind of cartilage. This is articular cartilage. Articular refers to articulation, or where bones come together. And you know this kind of cartilage, of course. This is going to be hyaline cartilage that makes up the articular cartilage, which gives that kind of a smooth surface for bones to slide past one another. Okay, the inside of the diaphysis, we have this region called the medullary cavity. And you see it here again. This has stuff filled in here. Here is kind of hollowed out so you can see the inside of it. It contains, in adults, yellow bone marrow. Yellow bone marrow actually is just fancy talk for triglycerides or fat. Yeah, we store some fat inside of our bones, at least as adults. As kids, we don't have that. Kids, we have more active spongy bone, and we'll talk about that in just a moment. The other part I want to mention here, let me clear out here, is to talk about the kind of bone itself. The bone you're seeing from here to there, and better seen from here to there, that represents a kind of bone called compact bone, and you see it here. Compact bone is going to be very dense, as the name implies, and it's going to be strong bone, and we'll talk about that more in just a second. In the heads of certain bones, you're going to have this spongy bone. Spongy bone is called spongy not because it's soft and squishy, but because it has far more holes and spaces in there, and you'll see it better on the next slide. Within the spongy bone, you're going to have your red marrow. Red marrow is hematopoietic. That is, it makes blood cells. So that's where we produce our blood cells, is in the spongy bone, rather the marrow that surrounds the spongy bone within most of our long bones. So that gives you a little bit of an idea of the difference. You can't see the spongy bone on this slide very well, but you'll see it a little bit better on the next one. So let's go have a look. This gives you a very similar view, but it shows you the difference between spongy and compact. Again, here is compact bone. It's this part of the bone here. Again, this is the periosteum on the outside, but from here to there represents compact bone. Here, from here over, represents spongy bone. And again, notice how you have these little beams that go through here. Again, I want to emphasize these are not spongy soft, but just kind of spongy, looking like a sponge, kind of holy. These little beams are called trabeculae, and you'll see them more in just a second. And they just represent a pretty strong network of bony protrusions. But again, all throughout here is going to be marrow, and the marrow is going to be producing our blood cells. Okay, so let's focus on compact bone for now, though. We'll talk about spongy bone a little bit later. We look at compact bone, and let me go back just for a second so you can kind of get oriented here. Okay, if you see these little holes here, these little tubes, and let me go back, sorry. Having some problems here. You can see it better here as well. You see these little tubes. Okay, these represent what are called osteons. Osteon is going to be essentially a bone unit, and the bone unit has these elements to it. The center of that osteon has something called a central canal. It also is called a Haversian canal. Okay, and passing through the Haversian canal are going to be blood vessels. Again, please get past the idea that bones don't have blood. I guess bones are very vascular, so they do. So you have in the center here, you have a central canal, Haversian canal, and then you'll notice you have these rings, right? And you kind of see the rings like a target. These rings represent what are called lamellae, and these lamellae are essentially growth rings, kind of like you would see with a tree. And they represent different amounts of growth over time, and we'll talk about that more in a second. You also can see some of the rings that are kind of here on the outside, they're kind of broken. These are called interstitial lamellae, that is, they are in between the osteons. So the ones that make up these lamellae are sometimes called circumferential lamellae. You'll see that term on the next slide. But interstitial are the ones that are kind of in between, and you'll see how they form in just a second. Finally, though, you'll see these little dots in here, right? These dots are called lacuna, and lacuna are like little rooms, if you will, and they have an occupant, and we'll see who lives there in just a second. But somebody lives in the lacuna, and every time I hear lacuna, I think Lion King, like Lacuna Matata, or not. Okay, so here's a little better view, and it's a little easier for us to see the different elements of compact and even spongy bone here. Let's talk about spongy bone just for a second while I get on the slide. Again, you see the trabeculae, you see these beams, and while this bone may look weak, actually the trabeculae give the bone a little bit of strength. And again, remember, all throughout here, you're going to have your bone marrow. But let's focus on compact bone. Again, you can see how they pull these out, so you can see them a little easy here. Here are the osteons. Here are the blood vessels that are passing through the Haversian, there it is, the Haversian or central canals. So here's an osteon, and you see the blood vessel that passes through it. You also have these horizontal blood vessels, if you will. These are called perforating or Folkmann's. I know it says there's a V there, but it's pronounced with an F. Folkmann's canals. These canals allow blood vessels to go from one osteon side to the other. Notice you have, again, your periosteal membrane, but notice how the blood vessels actually perforate and they come in. And these periosteal blood vessels are going to be pretty important as we talk about how bone grows. But that's how blood gets into here, is through these perforating or Folkmann's canals. Blood can actually get all the way to the inside of bone. So back up here again, notice the little dots, and we said the dots are going to be lacuna. We'll see those better in just a second. You see the lamellae, these rings, and the rings come from as bone grows, and that'll be clearer on our next video how that occurs. But let's go ahead and just do a zoom in here, if we were to take this section of bone, let's look very carefully at it. Notice how we have a couple of lamellae, a couple of rings here, and a couple of lacuna in there. So let's zoom in to see this. Okay, so everybody oriented? Okay, what you're seeing in this view is this white stuff, white stuff, white stuff. Okay, these are lamellar rings that are the matrix. That is, this is the calcium and collagen and the phosphate that makes up the bone. But the spaces we see within there, of course, we saw before as little black dots. These are lacuna, and who lives in the lacuna but osteocytes? Remember, osteocytes are mature bone cells that kind of got trapped into the matrix. Here's where they live. So to me, in my own world, bone is in a big apartment building, and these are the individual apartments, and the osteocytes live in the lacuna. Also notice, though, there's little cracks, if you will, in the bone, and how the projections of the osteocytes actually come out and touch each other through these small cracks. These cracks are called caniculae, or caniculus for singular. So osteocytes are actually touching each other and communicating to each other through the caniculae. Now, good question is, what do osteocytes talk about? Well, as we mentioned in the last video, if the bone is getting stressed, the osteocytes may become more metabolically active and tell each other, you're going to have to maintain your matrix. We may have to lay down some more bony matrix here because the bone's under a lot of stress. So the osteocytes are kind of talking to these little channels so they can tell each other about making sure they're doing enough to maintain the bone. So again, I'm going to go back real quickly. No, I'm not. Yeah, I am. I'm going to go back real quickly just to kind of remind you of the structure. When we're talking about lacuna and on osteocytes, we're talking about inside these tiny little parts as we move through. So again, here's another view. Central canal. Here's the lacuna, and within the lacuna live the osteocytes. The osteocytes are maintaining that bony matrix so that we can maintain that bone strength under different kinds of stress. That does it for this video. The last video will deal with how bones grow. Thank you very much.